Hi everyone, welcome to the PlatformCon 2024 and to this talk about platform engineering, DevOps, open source, and much more. Mainly today we will talk about a recommended architecture to help to reduce the cognitive load of stream-aligned teams to focus on their core business and generate value for the end users and make the company more competitive. My name is Caio Medeiros. I'm leading now the DevOps adoption journey at City, and I had the chance to meet David when I was working in Red Hat. And today he will be here with me to present this amazing topic, right, David?
Thanks, Caio. I'm glad to be with you in this great day. Just like Caio said, currently I'm a senior consultant in Red Hat. I'm working with several customers to accompany them on their journey of digital transformation. In addition, we collaborate together in the open source Santiago community. So, Caio, the stage is yours.
We are used to present this kind of topics explaining the why first. So we will show you this problem statement we have prepared to introduce this recommended architecture. But for sure, almost of you already know about DevOps. It's something massively known from 2010 and still growing today. Even before this, with all the different books that were written by some important persons in this matter, like the DevOps Handbook, Accelerate. So almost of you already know about DevOps. We will not go deeper in DevOps. We will consider that DevOps is already in place. Same thing with platform engineering. Maybe something uh, new, but we already know about this even before 2023. And we know that speedy. That's the reason we are today here in PlatformCon. I will not speak even deeper on agile, lean, design thinking. We will suppose that all these matters are already in place and you already know about this. Let's focus on the main problem we have. And to understand this problem, we have this case, which is the case of any string aligned team, right? We will have these string aligned teams with the multidisciplinary persons working together to have their product. And only during their daily work, they already have to know about their core business, the reasons to have their product, the programming languages to generate the software they will have, and the integrations with other systems. And finally, how to build, test, and deploy the whole application throughout the process to go from ideation to reach production. In other side, we have the platform teams providing this set of tools and platforms needed during the whole life cycle to build, deploy, to test. So during the flow, platform teams they will be providing these tools, but they also need to know how to build and deploy, how to maintain their environments, and provide monitoring tools. Why I'm talking about all this? Because if we suppose we have this case where screen alignment teams and platform teams they are working together, something that supposedly we already know and we have implemented with all the DevOps and agile mindset practices implemented, where a string aligned team will go from ideation, then develop, test, and deploy their software, and have platform teams providing these solutions. Probably they will have some numbers behind this related with cognitive load. So I took some of these different numbers and to start talking about them and talking about cognitive load, let's understand how many technologies and platforms they have. In one part, they have the technologies and platforms they need to maintain and develop. String aligned teams are product teams. They have to know or have deeper knowledge on their technologies to develop and generate the software they will provide to the end customers. So they will, in this case, this fictitious case we are proposing, they will have a view, Golang, and Redis to manage their application. So three technologies, just as an example, to maintain and develop throughout the software development lifecycle. But also during their daily work, they will have to use other 16 applications and platforms. to perform the different actions and tasks they have from ideation to deploy to production. In other side, we have the platform teams. And based on this fictitious case, they will have to manage more or less five technologies, maintain and develop them. But also, they will have to use these 16 technologies that streamlined teams will have to use as well. Because at the end, platform teams, they are product teams. Also, to start going deeper on these numbers related to cognitive load, we identified some of the matters behind it. One of them was the training time. The training time needed to get prepared to manage or to go through the different phases of the software development lifecycle. Mediation, where we will have technologies like Confluence, Draw.io, and Jira to document our ideas, the requirements from users. Based on the research we did on the e-learning platforms, more or less any person will require 12 training hours to be prepared, at least to have the base knowledge to use the tools and go from a customer request to have it implemented. And in develop phase, we have Jira, Bitbucket, Sonarlink, Jenkins. All these are just examples. Same things for test and deploy, where we have the main problem. And we want to highlight here, because there we have 50 training hours. But just not to focus on training hours, we brought also some other topics or edges to measure or identify the cognitive load in each of these phases. We have the screens used, the lead time required to finish the whole process, and also the difficult level. And based on these measures we did, we identified more or less the percentage of cognitive load in each phase. And focusing again in the deploy phase, we can understand that 40% of the cognitive load of string-aligned teams and even platform teams are related only with the deployment phase. That reduces a lot the capacity of teams to focus on generate more value. And I had experience working with some teams that they had a lot of barriers to move from test to production because they didn't realize operation tasks during the development phase, and they just realize this during the final phase when they are promoting from pre-production to production. So to put more on this fictitious scenery, we want to introduce the importance of reliability and stability, because any organization will require to have it there. That's the reason we are having more and more multi-cloud solutions in different organizations, where the string-aligned teams, the product teams, they need to deploy, release, and maintain their products in different cloud providers, or even in some cases sharing on-premises environments with cloud environments. So we have a solution, and this solution will be presented by David on how to centralize and make it more abstract. Go ahead, David.
Thanks, Caio. So, what is the architecture that we want to share with you today? We propose a single point of administration and work, regardless of the cloud provider Kubernetes distribution that could be used, and abstracting teams from the complexity that having to manage several technologies in the deployment stage. Even on-premise client environments could be used in this solution, allowing the use of hybrid clouds with other similar technologies like OpenShift. What we propose is to put ArgoCD as the unique and main access point to deploy for the streamlining teams, decreasing the cognitive load of these teams and this stage, as Caio mentioned previously. And on the other hand, for the platform team, there will also be a reduction in a cognitive load, since they will only have to worry about maintaining mainly a single product, and will be able to allocate more time to making the improvements they deem necessary, focus on improving the platform. In conclusion, we have estimated that there is a reduction in the cognitive load to 14%, fundamentally since the team does not need to learn and manage those cloud providers than other architectures are currently used, allowing the gained time to be used to improve know-how on the same platform or even invest it in other actions that can give greater value, for example, for the business. Let's see how this architecture works in the following demo for product teams. In this demo, we assume that the platform team has already made the platform available for use by the Simulate team. So the repositories that the developers will occupy and the 4 Kubernetes clusters where the application will be deployed have already been defined. 2 production, 1 UAT, and 1 development cluster. This way, developers can begin deploying their applications without needing to know which technology provider is behind them. This deploy can be done automatically by a continuous integration tool like Jenkins or manually as we show in this demo. We start by defining the application for development called podinfodev along with all its attributes. Project name is default, sync policy and automatic. The repository has been defined, so it's only necessary to indicate the path of the place where the application manifests are located. In this case, the path is customized. And finally, the developer must select the cluster and namespace for development. With this, the application has already been created and ArgoCD begins to deploy all its components. And after a few seconds, we have successfully deployed our application in the development environment, which can be reviewed in the same interface. With our application deployed in dev, the same developer can begin to test his application by modifying parameters in the same ArgoCD. In this case, he modifies the minimum number of HPA replicas and validating that is in a healthy state. It is even possible to review the pod logs in case there is a problem. This way, he can make a test change locally without having to go to the GitHub repository and constantly have to make new commits. Then, once the development team finishes the building of the application, the process continues with the deployment in a similar way, but now towards the UAT environment, where it will be subjected to tests defined by the team. Once the tests have been approved, we proceed to deploy the application in the 2 productive Kubernetes clusters. Okay, now we have our application deployed to production. And using the same ArgoCD administration screen, we can filter by environment, for example, to have a better view of the components. Okay, we can even simulate a productive failure, for example, by eliminating a pod that is having problems. In the same interface, we can perform troubleshooting by reviewing logs to find the cause of this possible error. Finally, we can say that ArgoCD is the single point of administration for the entire platform, significantly reducing the cognitive load for teams.
In conclusion, the main benefits of this architecture are reduce the skills needed to deploy, release, and maintain software products on multi-cloud environments, which allows for more robust solutions since they do not depend on a single cloud provider. Second, reduce the preparation time for new joiners or the list of requirements hiring, and make it easier to find people since they don't have many skill learners beforehand, and provide abstraction to have streamlined aligned teams focus on generate value to customer and not spending time on more administrative tasks. So Caio, would you like to add something else?
Sure, David. I want to highlight the importance of cognitive load. Taking care of this and implementing these kind of solutions like ArgoCD to abstract other platforms and reduce the amount of skills needed and time required to promote from ideation to production will help not only in IT areas, but also in the other areas like human resources. I hope this architecture and this presentation will help more than one of you, and please keep enjoying the PlatformCon 2024.